Hello. Okay, so I'm going to record this video on logarithmic functions. So I have a feeling some of you guys are going to struggle with this, but it's okay. Hopefully this video will help. So I'm not going to go over module 15 and 16 in your book. Obviously, you guys don't even have your books. So what I'm going to do is I'm just going to give you a basic summary. Okay. So given the following graph, so let's say I gave you this graph here, how would we determine the inverse? So you may have forgotten from quarter one, I believe, how you would determine the inverse of this. So let's go ahead and define our function. So our function is defined of the point, so I see this is -2 comma -4. What I have here, this is 0 comma -2. What I see here, this is 1 comma 0. This is 2 comma -2. And this one is going to be 3 comma 1. Okay, so this is our function. We have to determine the inverse. Okay, so in order to find the inverse, if you guys remember this, the inverse of this function can be found by swapping the x and the y values. So if we swap all the x, y values for this, this is -4 comma -2, this is -2 comma 0, this is 0 comma 1, this is -2 comma 2, and this is 1 comma 3. All we're doing is we're swapping the x's and the y's. Okay, so let's go ahead and plot these points. So the inverse is going to be -4 comma -2. One other point is going to be -2 comma 0. One of the points is going to be 0 comma 1. One of the points is going to be -2 comma 2. So that's up there. And another point is going to be 1 comma 3. So that's going to be up there. So if you kind of see this here, kind of shows a mirror image. If I were to just reflect it along that line, y equals x. So that is actually what is supposed to happen with this, if you're wondering. Is that would represent the inverse of this function, the dots that you see there. Okay, great. So now you're probably thinking, why did I even go over that review topic? So hopefully this will help you understand logarithms. Okay, so this black curve is something we've done in class. So we call the black curve. One of the things we did right before the quarter ended, we graphed this function. So f of x equals 2 raised to the x. This is called exponential function. It's called exponential function because it has a base, and this base is going to, in this case, it represents exponential growth. It's greater than 1. Okay. Now if we want to consider this pink curve, so this pink curve is this one here. So this is called a logarithmic function. So this function can be written as, so f of x equals the log with base 2 of x. So that's what I put here, just so you can see it. Logarithm with base 2 of x. Okay, so if you look at this, if you compare this graph and this graph, if you notice this exponential function and this logarithmic function, if I were to kind of turn this around here, you can kind of see that the logarithmic function is just a mirror image of the exponential function. So what this implies is that the inverse, so because it's a mirror image, the inverse of an exponential function is called this pink curve. So this is called a logarithmic function. Okay? All right. So next part. Let's consider one of the points on the logarithmic function. So one of the points on the logarithmic function, so this is our function, f of x, or y equals log base 2 of x. So let's say we're to choose this point here. Let's say we're to choose this point 8 comma 3. Okay, so we know that x is going to be 8 and y is equal to 3. So let's say we're to just look at this part here. If we look at this part, So it says, since x equals 8, we can rewrite this. So y equals log base 2 of 8, because x is 8. And what we know from this is y is equal to 3. Then this means that the logarithm with base 2 of 8 is going to be 3. But you might think, what does that even mean? So yeah, I know that might be kind of weird to see, but let me try to help you out with this. So basically, this expression, so log base 2 of 8, can be thought of as what exponent, I put that specifically in yellow there. So this is what exponent are you raising the base of 2 by to get 8? So this here is the base. You're trying to see what exponent you're raising to get 8. So I'll clarify that one more time. So this here, what exponent are you raising the base of 2 by to get 8? Okay. This is what you see here. So one way to do this, just guess, well, 2 times 2 times 2 is going to be 8. So this means this 3 is what's here, if you're wondering. This means log base 2 of 8 is going to be 3. Okay? So, yeah. Just try to see if you understand that. If you need to play back the video, you can play back the video if you need to understand that. Okay, so this definition is not in your textbook. I took it from a different textbook, but I kind of like the way that it presented it here. Okay, so for logarithmic function, if this, x is a positive number, then the log of x to the base b, so this base has to be greater than 0, and it can't be equal to 1. These two forms are going to be interchangeable. So you can change this to make it like this, and you can change this so you can make it look like this. Okay. We'll probably focus more on how to convert from both of the forms, maybe in the next packet that I give you. But I just wanted to get you used to that idea. Okay, so just so you guys can kind of see again, just so what's happening here. So here, just kind of connecting this. So y is 3. The base is 2, x is 8. Our base is 2, our exponent is 3, and x is 8. So it's important, so when you try to identify logarithms, you need to identify the base, the answer, and exponent. So let me go ahead and write that here. So I'm just going to go rearrange this. This is basically the same thing as log base 2 of 8 equals 3. So this is your base. This is your answer. This is the exponent. Look at what it spells. It spells bay. It spells bay. Yes, I got that idea from Mr. Cam, if you're wondering. But yeah, so that's one way you can kind of think about this. If you see a logarithm, the small number is the base, the next number is the answer, and the number on the outside is the exponent. Okay, so what I'm going to do now is I'm going to give you some examples. So I'm going to give you some examples here. Okay, so we want to find log base 10 of 10,000. Okay, so in other words, you want to think what exponent are you raising the base of 10 by to get 10,000? That's one way that you can rewrite this. So if you think about it, well, 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is going to be 10,000. This means x is going to be 4. So this means the log base 10 of 10,000 is going to be 4. Okay, if we have this, you're thinking, what exponent are you raising the base of 4 by to get 1024? Okay, so 4 times 4 is 16, 16 times 4 is 64, 64 times 4, 256, 256 times 4 is going to be 1024. X is 5, so this is 5. Okay, this one, what exponent are you raising the base of 3 by to get 9? Okay, 3 times 3 is going to be 9. X is 2. So log base 3 of 9 is going to be 2. Okay, this one. So, what exponent are you raising the base of 7 by to get 1? So, anything to the 0 power is going to be 1. X, anything raised to 0 power is going to be 1. So x is 0. So this is 0. Okay. This one, what exponent are you raising the base of 4 by to get 1 over 16? Okay, so one way I see this is, so 4 squared is 16, but we have to get this in the denominator somehow. So recall that rule, it looks something like a raised to negative m equals 1 over a to the m, something like that. We went over that in class. So if you have a negative exponent, this throws your result in the denominator. So what I see here is, if I have 4 to the negative 2, this is 1 over 4 squared, which is 1 over 16. Sorry, that 2 came out kind of bad. This is going to be 1 over 16. This is x. So x is going to, x is going to equal negative 2. So this means up here, this is going to be negative 2. Okay. For this one, what exponent are you raising the base of 5 by to get 1 over 125? So if you try to do it, 5 times 5 is 25. 25 times 5 is going to be 125. So we know if we do 5 cubed, we're going to get 125. But we need the 125 in the denominator. So what this implies is, try 5 to the negative 3. 5 to the negative 3 is 1 over 5 cubed, which is 1 over 125. So this means x is going to equal negative 3. This means this result here, these are all our results. Okay? Right. So there's one more part that I want to show you, and then I will close up this video. Okay? So now I want you to think about how each of these problems are evaluated. So again, if you want to do it, I can show you a different way now. So I show you the way that I did it. If I try to do it Mr. Cam's way, right? This is our, so if you think about it, this is our base. This is our answer. What we're trying to find is an exponent. So this is our base. If we say this is x, this is our base. This is our exponent. This is our answer. Okay, so 6 raised to what power is going to be 216. So if you do 6 times 6 times 6, it's going to be 216. X is 3. So this means that the log base 6 of 216 is going to be 3. Okay, this one. So log base 7 of 49. So same way. If you try to think of it the way that I presented earlier, yeah, Mr. Cam, that guy. So this is our base. This is our answer. This is our exponent. B-A-E. B-A-E. Bang. Okay? So this is, if you try to think about this, 7 times 7 is going to be 49. X is 2. So log base 7 of 49 is going to be 2. Okay, same idea with this one. So if I have this here, this is our base, this is our answer, this is the exponent. Okay, so 3 raised to what power is going to be 81. So 3 times 3 times 3 times 3, x is going to be 4. So what I see here is that this log base 3 of 81 is going to be 4. Okay, so you can do the same thing. Same thing with this one. This one is our base. 1/8 is our answer. We're trying to find an exponent. Okay, so 2 raised to what power is going to be 1/8? Well, 2 cubed, 2 times 2 times 2 is going to be 8. But we need that 8 in the denominator. So in order to throw it in the denominator, this has to be a negative exponent. This means x has to equal -3. Okay. Log of 15 of 1. Okay, so this is our base. This is our answer. Our goal is we are trying to find an exponent. Okay, so if you think about it, anything to the 0 power is going to be 1. So x equals 0. So this means that log base 15 of 1 is going to be 0. Okay, so now I did the 5 the way that Mr. Cam would present it to you. I'm going to present it to you the way that I showed you earlier. Okay, so the way I showed you earlier, so you want to see what exponent are you raising the base of 5 by to get 1/5. So if you try to do this, if you want the 5 in the denominator, if you try 5 to the first power, that's how you get 5. But the problem is, in order to get that 5 in the denominator, this exponent has to be negative. So this is x equals -1. So this is going to be -1. Okay. For this one, what exponent are you raising the base of 9 by to get 1/81? Okay, so try to do it. 9 times 9 is 81. We need this in the denominator. Since in order to get the denominator, this has to be negative. X equals -2. So this is -2. Okay. Log base 12 of 12. What exponent are you raising the base of 12 by to get 12? Okay, so if you try to think about it, well, 12 to the first power is going to be 12. X is 1. So this is 1. Okay, this one, log base 2 of 64. So if you try to do this one, what exponent are you raising the base of 2 by to get 64? So if you try to do it, 2 times 2 times 2 times 2 times 2 times 2, I believe that's 64. So x is going to equal 6. Okay, so log base 2 of 64 is going to be 6. Okay, I'll just close up for right there. So I'll show you this next part in the next video, but hopefully that helps you understand the first part of logarithms. Okay.